guys, welcome to our very first physics tutorial. This is 1.1, Evaluating Measurements. So our learning goals today is that we hope to be able to compare the terms of precision versus accuracy. We're going to be able to look at a set of data and compare whether they are precise or whether they are accurate or whether they are both or neither. We're going to calculate range using a formula. We're going to calculate percent error using a formula, and then we're going to learn about the terms accepted values versus theoretical values. So let's start by talking about precision versus accuracy. Precision actually has nothing to do with a correct answer and has everything to do with consistency. So precise data is something that can be repeated over and over again, where we're hitting a similar value, and it's basically giving us data that's very consistent. It doesn't necessarily mean that that data is accurate, although it can mean that, which we'll look at later. But precision has everything to do with consistency of data. Accuracy, however, is not concerned with how often the data can be repeated, but is concerned with whether or not it's near the correct value. So to be accurate means to have the right answer, even though they may have messed up many times before they were actually accurate. Let's look at these four diagrams. I think a bullseye picture is actually the best way of explaining accuracy versus precision. In this first picture, you can see that the data points are all over the board here. Think of this in relation to numbers. So if I were to give you a numerical example of this picture, I would say that so-and-so measured a ruler on a ruler. They measured a penny to be 1.5 centimeters. Then they measured it again, and it was 2.0 centimeters. And they measured it again, and it was 0.8 centimeters. Then they measured it a fourth time, and it was 1.0 centimeters. These data points are all over the place. So let's say that the actual length of the penny was 2 centimeters. Okay, that would be represented by this dot right here. This dot right here would be the accurate dot. But all of these dots over along the board are different values that are not close to the actual value. So this would be an example of data that's not accurate and not very precise. So even though they hit the point one time doesn't mean that they had very accurate data. This one data point would be considered accurate, but since all the rest of the data points are all over the area, then it would still be considered that the data is inaccurate. You can think of this as an example of a student that's in a lab and they're doing an experiment and they have no idea what they're doing and they're getting all sorts of weird answers, and then accidentally they hit the right answer one time. Now let's look at the second example. Here you can see all the data points are very close together, even though they're not near the target. So this would be like if I measured the penny and it was 10 centimeters, 10.1 centimeters, 9.9 centimeters, and another 10.0 centimeters for the penny. So those are very close together, very precise, but they are inaccurate because the penny, like we said, was 2 centimeters. And so it's nowhere near the correct value. So we would call this to be low accuracy, not near the actual value, and high precision. So the way this would look out in the lab is if you had a student that was very meticulous and was doing the procedure correctly every single time, but there's something wrong with the way they're doing the procedure. Even though they do the same procedure the same way every single time, there's something wrong with the procedure because they're getting the wrong data. Now let's skip this third one. Now let's look at the fourth one. Here we can see that the data is very precise. It's all very close together and it's accurate. So this would be an example if we had someone measure the penny and they got these data points out. These are very close together data points, so they're very precise and they're within the accepted range. They're very close to the accepted range, so they're highly accurate. So this would be an example of a student in the lab who was doing the lab properly and being able to repeat it over and over again. Here's an example of a student that is getting close to the right value, but they're not very precise data. So it's still close, but it's not super precise. And so they would be a student who is making some mistakes through their lab procedure, but overall is getting it correct. So now let's look at an actual problem with these numbers. Example problem number 1, we are given an accepted value. So accepted is the actual value of a measurement. Okay, that's what the accepted value means. And here the accepted value is that the density of silver is 10.5 grams per centimeter cubed. We're going to use the average values of these 3 measurements here. Here are the averages for group A and the average for group B to describe whether a set is accurate or precise, which one is which. So let's first look at the data here. Here we have 13.2, 11.9, 7.4. Those numbers are kind of all over the place. So we would say that this data is imprecise because it's kind of all over the place. Let's look at this data. 12.6, 13.8, and 13.1. Those are much closer together. So I would write down that this data is precise or more precise than group A. Next, let's talk about accuracy. When we're looking at accuracy, instead of looking at individual data, let's look at the average of the data, okay, for both of these. And let's look at the actual value. So the actual value is 10.5. Group A's average was 10.8. That's pretty accurate, very close. Group B's average is 13.2, and that is far away from the actual value, so we would say it's inaccurate. So this is when I ask you to describe or to compare precision versus accuracy in a set of data, this is what I'm asking you to do. I'm asking you to tell me which set of data is more precise and which set of data is more accurate. Now, there are actual ways to come up with a numerical value to calculate accuracy and precision. So that's what we're going to look at next. Accuracy in a set of data. So if we are looking at a set of data, the first thing we do is we need to calculate the average value of the data set. This is going to be what's called our theoretical or measured value. So in group A, this is the theoretical value. And in group B, this is the theoretical value. Now we want to compare it to the actual value, and we do that by using a formula called percent error. And so the percent error formula looks like this. It is your actual value, which in this case is 10.5 right here, 10.5, minus your theoretical value, and that's going to be different for each set of data. So for group A, the theoretical value is 10.8. For group B, the theoretical value is 13.2. We're going to divide that number by the actual value again, and then we're going to multiply that answer by 100 in order to get a percent. Now your percent can either be a positive percent or a negative percent. A negative percent ironically means that you went over the accepted or actual value, and a positive number means that you went under the actual value. So let's go ahead and calculate percent error for both of these. So let's do percent error for A. Our group A is going to be 10.5 minus 10.8, that's the average, the theoretical, divided by 10.5 times 100, and that gives us negative 2.86%. That means that the value that group A measured was off by 2.86%. Now let's calculate percent error for group B. is going to have 10.5 here, just like the other one, because the actual value doesn't change, minus the theoretical value that they calculated, which was 13.2, divided by 10.5 again, multiplied by 100, and it gives us negative 25.7%. So that means that this group of data points from group B was off by 25.7%. That's a huge amount. In fact, if you have a percent error that is between plus or minus 5%, that is considered a good percent error. If it's off by more than 5%, we would say that their data are inaccurate. Okay, now let's look at precision. How do we calculate precision? We are going to calculate how far apart the values in a data set are. And so we're going to use the formula for range. So range, the range of any values is you take the highest value, you subtract it from the lowest value, and that gives you your range. So let's look at group A. Group A's data, let me do this here. Range for group A is 13.2 is their highest data point, 7.4 was their lowest data point, so their range is 5.8. The range of group B, their highest data point was 13.8 minus their lowest data point of 12.6, and so their range is 1.2. So we can see that this is more precise. Their data points are closer together, they're more consistent. And that this group is imprecise, especially compared to group B. Okay, let's look at one more example problem. We are not going to calculate out the level of accuracy or the percent error or the precision or the range. Instead, I was just going to walk you through comparing precision and accuracy. Now, and a good example test question would be to ask you to compare accuracy and precision in all the data using words, and then to back it up mathematically. And so if I asked you to back it up mathematically, in order to calculate accuracy, you would be calculating percent error. And in order to calculate precision, you would be calculating range, okay? But we're not going to do that step in this example problem. Okay, first, let's look at student A. Student A has three trials, 2.6, 2.7, and 2.6 again. Those data points are pretty close. Let's look at student B. Student B has 1.5, 1.5, and 1.5. Those are very close. And student C has 2.1, 1.5, and 3.2. So I would say those are imprecise data. So let's look at student A in regards to precision. Student A is precise, so we'll put a check mark. Student B is imprecise, so we'll put an X. And student C is, I'm sorry, I did that wrong, didn't I? Student B is precise, and student C is imprecise. Now let's look at accuracy. For accuracy, we are going to be looking at their average. We always look at their average, and we're going to compare it to the actual value. And so here we see 2.62, 2.67 is very close to 2.69. If we look at student B, 1.5 is very different from 2.6. And then here for student C, we see 2.3 is still off. It's not close to 2.6. So we're going to say student A was accurate, student B was inaccurate, and student C was inaccurate. And so the way you would describe them, if I was asking you to write a couple sentences about this, is you would say student A's data was accurate because it was close to the accepted value, and it was precise because the data points were close together. Student B was inaccurate because it was far away from the actual value, but it was precise because the data points were close together. And student C was inaccurate because the data points were far off from the actual value and the data points were far apart. So they would be imprecise as well. All right, and that is it for this first video.